So what is my favorite feature of the Azure Cloud Shell? So just aside from the ability to open up a Cloud Shell or a shell inside of your Azure portal, I would have to say my favorite feature is that we've packed some really good applications into the Cloud Shell for you by default. Not to mention that you just click a button and that shell pops open and is authenticated to your subscription. But we have tools, popular DevOps tools like Packer and HashiCorp Terraform. And that allows you to do things like take a Terraform code base, put it right into your Azure Cloud Shell, which is using persistent storage, by the way. And you can actually run that Terraform code. You can have it actually spin up resource groups, build VMs, build networks, all through that Cloud Shell. It's a great way to test really quickly if you've got some code, you want to see what it does, you want to see how it works. Really, really great resource. And also the Azure command line interface, the AZ CLI, is built in as well, and it's authenticated. You can use that to do things like check on servers, build things, anything you can do with the AZ CLI, you can do that in the Cloud Shell as well.
So, my application runs on Linux. Am I ready to use Azure? You know, it's a funny question that I've been asked a lot. People always make this assumption that Azure is a Windows-forward platform, but let me tell you, that's not really the truth. Sure, we have Windows, we have tons of Microsoft products that you've probably used for years, like SQL. But the one thing that's really great is that Microsoft has leaned so far into Linux. And let me tell you, Azure, it loves Linux. Between the VMs that you can run, all the different services that are extremely Linux forward, you'll feel very comfortable. And not to mention, we've got tons of pre-baked images. If you need that full operating system, you can use Ubuntu, Red Hat, almost any of these major operating systems that, you know, you've used forever in Linux. So don't worry about that. I think you're ready to get that application moved over to Azure. We've got all the resources you need to make sure that it works just the same as you've always deployed it, because it's still Linux.
Hey everybody, it's me, your buddy Jay. Welcome back to yet another Azure Fun Bites. It's been really great once again to have you all. I really appreciate lots and lots of people always coming and taking part in this, and so I really appreciate it. Good evening to you too. Thanks for watching. So we are live. We're here on LearnTV. We're here on YouTube, Twitch, Periscope. We're all over the place. Azure Fun Bites is global and well distributed. That being said, thank you very much for being part of my broadcast. Every time I do this, I try to give you a little bit more information on what exactly Microsoft Azure is and all of the different things that make up it. So there's different resources, there's different products, and different things that can help you accomplish more. So I've had conversations with people before about Linux, about Scale, about Go. But today I'm going to have a conversation about all of those things. And to help me do that, I brought along somebody. And it is none other than Aaron Wislang. How are you, Aaron?
Hi, Jay. Doing very well. How are you doing?
Great. So for those who are watching that may not know you, why don't you go ahead and tell us a little about yourself?
Yeah, so my name is Aaron Wislang. I'm a cloud advocate on the Cloud Advocacy's open source engineering team. I've been here on our team for about 3 years or so, coming up just a bit over. And I work on things like Linux, open source, Go, containers, Kubernetes, and a whole lot of collateral things around that as well. So I really enjoy the cloud. I really enjoy building simple and scalable systems. And it's a lot of fun.
Very awesome. Well, I want to thank you again for being part of this. And you and I have been able to go some places around the world together. We've done some of those Ignite tours. We've met up in different places that they bring our advocacy team. And so how are you getting used to being home more?
It's been great, actually. And one thing I've noticed is that our job is we of course we would show up in person at a lot of different places and all the rest, but the work of advocacy is still very much the same. We're just kind of doing it virtually. So it's very encouraging, and we're still able to connect with different communities all around the world. And some of the conferences that we deal with, they've gone completely virtual. I've often had greater reach as a result of going virtual. And we look at things like Ignite, for example, or PyCon or GopherCon. And it's been great to meet even more people from further geographically distributed parts of the world.
Very, very cool. Well,
I'm looking forward to when we get back to that, sort of being able to see people face to face and safely again. That's going to be fantastic.
Yeah, I really miss my coworkers, to be honest with you. Like there were so many awesome opportunities to kind of spend time together, learn from each other, do really fun things. And unfortunately, we're stuck doing it all virtually, but I still think that there's a place for us. Like, I still believe that we're able to kind of accomplish things that we want to do and learn about things, and also be able to share things with our respective audiences. And so it's always about making sure you can find the right ways to kind of connect with people. And so I really always appreciated the fact that you are part of that crew. And so I want to, before we get too crazy into things, I wanted to show everybody that we've got a poll up on the LearnTV website. So let me kind of share this for y'all really fast. I know when I'm doing it and I'm doing it live, it's always so fun, but here we go. 1 second. Let's show this right here and avoid some recursion. There we are. As you can see right here, we've got our poll. It's up here on the LearnTV website, so you can just go ahead, answer the poll. If you want to see, there's some questions that you can join the conversation right here. This is a brand new feature to the show, aside from what we're doing week to week with just our regular questions. It's really a great opportunity to hear from you all directly. So sorry about that little recursion. I'm still working on being the amateur producer that I am. But, hey, that's what happens when you do it live. So, Aaron, I want to talk to you a little bit about our subject today. And I think I can kind of start everything off with an image I think that will have some impact for everybody. You ready for this image?
Fire it up. Yes. Microsoft
I really think that this image kind of puts into focus the idea that what I just kind of talked about in that video, took that video. I don't know if you remember, that was like around the last time we were all together in the snowy area of somewhere in Washington State. But I remember us all getting together and recording those videos, and I really enjoyed talking about Linux on Azure. And the big reason why is that there's a bunch of misunderstandings about that go back for years about who uses Azure, why they use Azure, and what they use it for. But what we've come to learn is that Azure is an all-encompassing IT solution for almost any major service that you need to provide in the cloud, whether it's a database, Linux servers, Windows servers, containerization, which is just Linux anyway, all these things that are just so Linux forward, that are just completely part of the Azure experience. And I believe we're at a point where there's so much more running on Linux than anything else. Am I right?
Yeah, the majority of new VMs and compute workloads and all that thing has been Linux, and that's been true for some time. And I think this is also a natural offshoot of us just going where our customers are. Now, we know where developers are, we know what they want to use, and we really want them to use the tools that they feel comfortable with, whether they're first-party tools, third-party tools, or, multi-cloud even. So that's something we really focus on. And
Absolutely. So you've worked for quite a while doing software development and engineering. You worked at Rackspace, if I'm right?
Yes. Prior to joining Microsoft, I was at Rackspace in their Azure product engineering group. So we helped a lot of different customers in the cloud. We also had different groups doing different clouds as well. So we saw kind of the whole scale, the whole the spectrum of things and security stuff.
And lots of opportunities for hybrid type of solutions, considering the fact that, Rackspace has tons and tons of physical gear capable for their users that can integrate through using services like I forgot what is it, Express Route and things like that.
Yeah, and Azure be Express Route, and they had this whole hybrid model as well because they had their roots in the data center world. So they were building out data centers all around the world. Obviously, not at the scale we have at Microsoft now, but they came as a managed hosting provider, and they also built one of the large open source private cloud platforms at OpenStack. So they're very invested in that too. And then they moved into supporting the three major public clouds. So they had kind of the full view of everything.
Well, it's super important, I believe, to have breadth on these subjects because they really help you get what this show is about, the fundamentals, and understanding how the fundamentals come together to build things for our users. So I want to bring up a little something, and let me move this over here so we can kind of get started. And I think that this may be a really awesome place for us to begin our conversation. I'm going to do some screen sharing changes. Just take me a second. So let's do this. Share. So I think this is a really, really great infographic that we can kind of just touch on for a few minutes and then kind of get into more of the things that you're interested in talking about today. But I think that these are really interesting basics about that Linux is essentially the fastest growing platform on Azure, kind of like what we said. So one of the big things that we have here is Linux-based images comprise 60% of the Azure Marketplace images. And the one big reason I can think of that, Aaron, a lot of it has to do with open source licensing and the ability to not have to concern yourself with subscription-based licensing for every single image, making it very, very portable. The top 100 Microsoft customers deploy Linux workloads on Azure. Have you ever talked to one of these people? Or
talked to a number of them, actually, yes, at different scales and different levels of things they can share. But yeah, we did. We definitely. It's amazing to see the scale at which our platforms get used. I'll put it that way. It's Scott Guthrie often talks about this, and everything from car manufacturers to Starbucks and all of these other things. And one of the things I often reflect on is how many, when I deal with different customers and things, and time to time developers in all sorts of different places, how I can barely go through my day without touching a Kubernetes cluster at a customer that must be at a customer of one of ours. Like, you go to your groceries, you know that there's massive platforms being built on that. You go, your car is probably hooked up to something in the cloud that does X and Y, and then you go to all of these other things, banking, and it's just amazing.
Let's just talk about one of those top 100s, which is Walmart. Walmart is very, very well known public, discussed customer of Azure. And I would make an assumption that they're using, and I don't know off the top of my head, I haven't really worked with their account before, but I have to make the assumption that they're making use of these services that help them build more efficiently. And so this is another one thing that I think is really cool, is more than 50% of VM cores run on Linux on Azure. So that whole misnomer about Azure being a Windows forward type of platform, that alone, that particular number tells me that that's not the truth.
And we also have a lot of first-party parts of Microsoft which have been fully Linux as well. Some of them come by acquisitions. You look at, for example, Skype, and was very big Linux shop when they joined Microsoft, and huge deployments there. And companies like LinkedIn, which is a long-time acquisition now, vendors of Kafka and that sort of thing. These are very Linux native, companies that were doing this even before we were, as heavy into Linux.
Now, I was a big FreeBSD nerd. When I was working in a lot of break fix, like Linux and FreeBSD, like Unixy environments. And the fact that FreeBSD is supported, to me, for some of us who spent their years, slurping ports, getting them updated, manually updating kernels on FreeBSD, and doing inbox stuff, it's really nice to know that there are these images. Yes. And you can just start. So it's just the same with Red Hat, SUSE, Ubuntu, which tends to be the most common and almost at times the default images that most people pick. Oracle Linux, Debian, CentOS, CoreOS, which is big for our containerization, and then of course OpenSUSE, which is the free version or the non-enterprise edition. Unlike Red Hat has their enterprise edition, or you can choose CentOS. SUSE has their paid subscription version and their open source OpenSUSE. So we've got support for all these things, lots and lots of security features for Linux. I think that's terribly, terribly important. And then here's a big part of this that, we touched on for a second, Aaron. Containers.
Yes. One of my very favorite things,
And we'll talk a little bit more about those as we get in. There's 2 natively supported managed Kubernetes orchestration services. One is the AKS. We've talked about AKS on this program before, and we'll probably talk about it more. We'll probably talk about it some today. AKS is one of the fastest growing, most popular services on Azure because the world is driven by Kubernetes now. There's no getting around it. All the big apps that we're working with, a better portion of them are being driven by Kubernetes.
And I think it's also a spectrum as well, is that there's this huge growth in AKS, like you said, the fastest growing platform of all time inside of Azure. But there's also this wonderful spectrum where folks who come along and they just want their VM and they want to use the tools that they're very familiar with now, and maybe they don't need the complexity of container orchestration yet. It might be even simpler than that for you. You might be a developer who can put your application into the serverless paradigm and get that incredible cost, incredible scalability, and very low ops overhead in that sense, or operations approach. You've got the full spectrum, and you can kind of pick and choose what you want, what you need at each time across that spectrum, which I think is very, very important. You don't want to jump into something because it's the next cool thing. It might have great attributes for you, but you may not need it just yet. And I think that's a very important balance to strike. But across all of these things, whether it's a serverless function, whether it's a VM, whether it's a full-on Kubernetes cluster, all of this is basically Linux today.
And I love this one little part right here, and then we'll leave this area. I've heard about SQL. Can it run on Linux? And it says Azure SQL virtual machines run great on Linux. So we're talking about what we consider things that are very much native Microsoft tooling that we would always assume were part of using Windows. And that's not really necessarily always true.
And one of the other aspects is I've been on both sides of the house. I've always had a very strong focus on open source since very early in my development career, but I've also used a lot of Microsoft products, including the Windows Server and a lot of it, Windows itself as a developer machine, everything. I'm very focused on the cross-platform aspect of everything. And the aspect of being able to manage anything inside the cloud or anything inside Microsoft, use all our platforms without having to touch a Windows machine sort of ever is fantastic. You could be a developer running on your Mac like I am here and have a full Linux on the desktop if you're sort of like me. And you can be native to all of these environments just by using all of that.
And speaking of, that brings up a great way for me to kind of kick some stuff off. And then I'm going to throw it over to you to kind of show me a little bit of your tricks and tips. But what I really wanted to get started with is just Linux on Azure. You can go to the documentation. I will make sure it's shared. But we've got all these different options we talked about. But one of the things I want people to see is that we can always use, and you never have to log into a Windows server. You can start working with Linux services on Azure just from VS Code, which I thought was just really cool. So the first thing you want to make sure is that your Azure account extension is installed. And then once that's installed, you'll want to make sure that you sign in. So you'll get a two-factor authentication request. If you have two-factor, which you should have installed, configured, you'll be given that authentication bit. And then what you'll do is have access to manage and manipulate resources on your Azure account right from here in VS Code. And on top of that, we're Linux themes for VS Code. So if we want specific themes, if we need a Linux cheat sheet because we want to write up some scripts, if we want to do something with WSL, that there is some support in these native tools for Linux. And then let's not forget, if we go here to our portal and we bring up, and one of the reasons I showed the little Cloud Shell pre-roll video is that I want to remind everybody that we get a bash terminal right in Cloud Shell to start working with it, and we can use standard Linuxy tools. If I'm correct, I'm pretty sure this itself is a Linux image. Am I right?
Yeah, so this is actually running inside of a container, which gets spun up on demand for you, and it's connected to some persistent storage, so you can have files and things that you're working on, which will be there the next time around. But it's a really great way to get a quick access to a bash shell. I mean, PowerShell's there too, but this is the, I need my Linux tools, I need a command line, I need to be authenticated, and it's all just right there from whatever machine you're doing. We use this a ton in things like workshops, where you might have 100 people in front of you using all different machines from Windows to Mac to Linux, and they will just need a consistent environment they can get up and running in sort of 5 minutes or less. And
Gotcha.
Doing stuff in the cloud. And it's got Terraform and kube control and all of these other tools that you would expect.
Yeah. And just to show everybody here, right here is simple. I did a uname -a, which is a standard way of just getting what your kernel version and information like that. And here we see it's a Linux. And then if we do cat, LSB, or etc, LSB, I guess we don't have the LSB here that we can access. Maybe it's not that kind. I'm not really, yeah, it's an Ubuntu machine. Oh, and here we go. We don't even need to do the LSB. There's the version of Ubuntu that we're using right here. So very cool. We've got started, and we're kind of did our first kind of bits, and we're introduced ourselves to using Linux on Azure. And so now I'd like to kind of take this to the next step. But before we do that, we've got a question. You ready to answer a question?
Absolutely.
So it's a long one, and this is from TRP8472. And they ask, if there's a couple of things to focus on for someone new learning Azure, what would you recommend? Only do a little with Linux? Hence question. So they only do. Andy, thanks, Andy.
What I would suggest first and foremost is to find something that you would like to do in the cloud. You can, instead of looking at the tools that you're using, take it back to the thing that you want to do and find something small and that's of interest to you. Maybe it's a personal project, maybe it's something in day-to-day work, it might even be a side project within your work environment, and look at the tools that you can bring together to deploy that to the cloud. You might say, oh, I need to automate this small task, and that might be amenable to building something serverless with Python. So at that point, you're not dealing with any VMs or anything like that. So you're writing a bit of Python, and you're taking something which is a script, effectively could have been a script sitting on your laptop, and you're bringing it to the cloud. And then automatically you can run 1 million executions of that effectively for free, and have it very cost effective going forward. And you don't have to think about a whole lot of things. And you can kind of scale into other things. If you're used to virtual machines, you can start getting familiar with virtual machines. Start a small burstable instance, which is incredibly cheap, and SSH into that and work with the tools there and get familiar. Or look at, if you're more data-oriented, look at some of the database, managed database solutions we have there. Those are good ways to kind of scale into it. You don't have to kind of boil the ocean.
Yeah, it's as simple as just doing this for your very first Linux experience, I think, is just going into the portal, clicking a new virtual machine, giving it a name, new machine, picking where you're going to putting it in a resource group, obviously, picking where it's going to exist. In this case, I'll pick East US 2, the availability zone, or how many data centers within a region that you can be in, or which specific one, I should say. But you can add additional redundancy if you need to. Whether you want to use a spot instance, which means it's a discount on the virtual machine, how you'll actually authenticate. We always use SSH keys. Everybody around here, we want you to repeat in the chat. I want you to repeat. We always use SSH keys. We don't use passwords. The first person who types that, I will put your comment on the screen, because it's something that we need to remember.
And we have capability there relatively recently for actually generating the SSH key for you right there in the cloud. So that it'll store the public SSH key, it'll deploy your VM, create it, you can use it and that kind of thing. So things like SSH key management are getting much easier.
Yeah. I really love that there's the ability, and I can actually bring that up really quick too for our user or our viewers, is if you go, let me bring this here. So if we go here into our search and we actually look up SSH, we can see SSH keys. And what we can do is click new, and we can actually store a pair right in here, or we can even create a pair, whatever it is, and it'll be in a secure place that Azure will know to go to when it needs to inject a key. And that's right, Rick Rose, we always use SSH keys, always. That's right. Cool. So we've talked a little about how people can, take that very, very first step in Linux. So you have done a ton of development for Linux, for specifically Go.
Yes.
And so I'd like to hear a little bit about how do you set up your environment to start developing within Go?
Yeah, so Go is actually great because it's one thing I really love about it is it's completely cross-platform. It fulfills a lot of that cross-platform promise. It's a small language, so it's easy to pick up and learn. It is C-like. Don't think of it as C. I'm handling memory by myself, but it's higher level. It's garbage collected. It has great concurrency built into it. We have these things called Go routines and channels for communicating between these Go routines and so forth. And one of the reasons I like it and do a ton on the Linux side is because it is very widely used for things like APIs and CLIs and building infrastructure in the cloud. So it's considered a systems programming language. It's high enough level to be very safe and robust and so forth. But it's also has great overlap with other things that I might use. So I don't program in Go all the time. I love tons of different languages. I do a lot of Python. I used to do a bunch of .NET. I've done Go for a long time. I write a lot of stuff in Bash. And Go has this wonderful overlap between, hey, I've got something that was a Bash script and I want it to be a little bit more robust or to draw on some things that might be some like SDKs and stuff that we don't have available. And I can just flip my Bash script into a small Go CLI tool with relatively little overhead. If I'm building something against Kubernetes, that is just one of the largest projects that use Go. Docker also uses Go too, but in the Kubernetes ecosystem, there's just so many things which are just right there, which you can access from Go itself. And then the other aspect is APIs, even web services and websites, even if you wanted to go that route. It's just easy to spin up a self-contained service which runs as a single binary, just pops up a web server for us, and you're exposing your service or your thing to the world. And you can run that serverlessly. You can run it on a VM. You can run it on a Raspberry Pi. I've got a Raspberry Pi next to me, which I often run small tools and things on. And this is typically Linux, but you can land that on a Windows machine, or if you're building a CLI, you can cross-compile it very easily from any platform to any other platform. And I can say, hey, Jay, you need to use this tool. Go download the Mac version from this. Actually, funny I should say that. One of my favorite tools as I hack on things like web services and so forth is called Hey. So to give an example of what Go is good for is building small CLI tools that do one thing really well. And this is written by Yana Dogan, who is on the Go team at Google. She works in another place. And it's sort of a load tester that's similar to Apache Bench. So instead of going out there and saying, hey, many years ago, I'd have to go out there and download Apache Bench. Maybe it was for Windows or something, extract this binary out, find out where it was, then run it and all of that kind of thing. Great tool. But with this, I've just got a single binary that I can go out and grab, and I can start throwing load at one of my web services as well. So Jana's written a ton of different tools out there. But that's a good example of what it's good for. So I built lots of interesting small tools in the cloud using lots of different approaches.
Sure. Let's go ahead and take a look at, do you have like a little how-to or a little like hello world or something?
Yeah, let's pop something up. I'll share my screen for a second. In fact, I'll share something from.
And I'm gonna actually, Yana actually has, and Yana is really amazing. Yana spoke at my last event, which was the one I ran, DevOps Days New York City, here in New York City. she's really incredibly brilliant. And since leaving Google and going over to Amazon, just doing more amazing stuff. So I just went ahead and grabbed a little. And what we're going to do is just going to do it right here in here. And then I'm going to give you over. Just I want to show everybody. First of all, Go is right here already in the Cloud Shell.
Mm-hmm.
And what I went ahead is I downloaded this Go test that Yana provided. And if I'm right, I just need to make this, correct?
Yeah. So actually, maybe we'll flip back for one step actually instead of Go test. You can actually make that, but what we could do is use Hey itself. So
Okay.
if you wanted to, you could actually curl down that binary and just run that binary. But since you have Go on that machine, you can go to Rakel/Hey on GitHub, and you can just go get github.com/Rakel/Hey, and that will actually download and build that binary for you. So in that sense, the Go toolchain, which is super simple by itself, can actually act as a package manager which installs small binaries. And Go packages are stored typically inside of source control like GitHub. So they're available, they're referred to by their fully qualified name, so github.com/whatever/hey. And that's kind of the de facto package management capability for Go itself.
Oh, I see.
Yeah.
So I had to do this Go get here first.
Yeah.
So I didn't actually need to download the source
You
code.
didn't need to download the source
could
code. You can just go get. So if I build a binary, or maybe one thing I've been doing recently is I have a little a repo, it's a private repo actually, but which has a whole bunch of subfolders in it, which correspond to different binaries and different tools that I've done. And if I'm on a machine which has Go, I can just say go get ASW101/2021/hello such and such, and it will pull down and build the latest version of that binary for me.
Sure. So I've done this this Go, or I should say Go get. So after I've done this Go get, how's the best way to execute this Go test?
So let's not do it with go get. Let's just try it with Hey.
Okay.
Because that'll so we'll do go get github.com/Rakel/Hey.
Okay. Like this?
Yep, that's the one. Let's try that.
I don't need the Go test.
Yeah, just go get.
Sorry, when you type, everybody can watch you.
This is live. It's cool.
So this is downloading the and so that's one of the big things that I want to make sure people know is the cool thing about Go is it's a binary shippable language. So you can actually compile things that you build into binary so that they don't have to be in real time built by your application. What you can do, or you can build a binary and ship that along. So that's really been popular from what I know with like configuration tools, because you're shipping very, very light binaries rather than huge pieces of code along with configuration files and libraries and all these things. What we're talking about is like libraries that are statically linked, or I should say dynamically linked to these. So if I believe it's LDD is how to show links. So let's find which Go test. Is it
Actually,
under Go test?
which Hey? See if which Hey is there.
Uh-oh.
Maybe Govin's not safe. It's okay. Little.
Maybe it's just the here and there. But anyway, maybe we should let you kind of take over and do some of the heavy lifting. What do you think?
Yeah, sure. Yeah, I'll share my screen now for you. Okay, so actually we're going to dive into a bit of a hello world here. So what we were talking about there was how good Go was at building small binaries, which are easy to ship around and use for tools, everything like Docker and Kubernetes and Terraform and a whole bunch of other things, especially in the cloud native ecosystem. But if you want to look at some Go code for a start, I built this workshop actually, which I delivered at last GopherCon a couple of months ago. And this has some really good introductory examples of simple Go web services and other stuff that you can build, particularly stuff that works serverlessly. So one of the things I'd like to point out here is that Go is great for tools, it's great for web services, it's great for CLIs, and that also makes it great for serverless applications. Not just serverless as in, hey, I'm going to run this as a function inside of Azure Functions, but we're going to look at that, but also maybe inside of a serverless container. You can build a very small container using a single Go binary, which doesn't have any other dependencies, which you can run in something like an Azure container instance. Or if you think of GitHub Actions itself is kind of like a serverless platform too. If you just need to go out there and run a binary, run something on a schedule using a cron trigger, run something as part of your build process, that's also serverless compute because you're not thinking of VMs and all of that kind of thing. So if I go over here, so this is actually at aka.ms/go actions, so you could follow along with this. It's just by itself. And I'm going to dive into one of our little micro labs here. I'll just also mention here that another very cool tool that I like is called Hugo. This is a static binary for building static websites, and that's written in Go as well. And you can
absolutely love. Is that's Steve Francia who wrote that one too?
Yeah, so he's on the Go team over at Google, and he's written some other really good tools like Cobra, which is a framework for building CLI tools. That's used by Kubernetes and a bunch of other tools. We build lots of stuff with it. These are
I another New York local, someone I've been able to kind of meet and spend some time with. I'll go ahead and just so everybody can see who he is, just like we talked about Yana. Here's how you can find him for more interesting code. And then I'm going to also make sure Yana is shared in here because Yana is incredible. Like I said, always impressed with what she puts together.
And that's another aspect of this. Is one of the things I really love about Go, and one of the reasons I use it first and foremost is because of the community. The Go has a really great collaborative community, which is very welcoming to newcomers and so forth. And we get together every year at a conference called GopherCon that my boss, Brian Kittleson, the co-worker Eric St. Martin, put together many years ago. And it's fantastic. So
he's been on here before, and we're lucky enough to kind of have a conversation with him about Go as well. I think we're just doing a little different than we are today.
So this is Hugo. So if you wanted to build a static website with GitHub Actions and Pages, that's a great example. This gives you a deep dive. So we're not going to go into what a GitHub Action is in great detail. But if you want to learn more about what GitHub Actions is, you can learn it through the CLI tool and learning to build your first GitHub Actions workflow. And all of this runs in Linux. It uses a bash script that I put together here for you. And it doesn't use any external services and explains what a GitHub Actions workflow is. And pairing GitHub Actions with binaries like the Go builds is really, really powerful. It kind of brings that Unix philosophy to your CI/CD pipelines and so forth. But if we look at Go for serverless and containers in the cloud, we've got some examples here which cover things like Azure itself, so a generic workflow to use a single Go binary to do things like ship storage around. I'll give one example of this is our tool inside of Azure for working with Azure Storage is called AZCopy. That is also written in Go. We did that. We flipped it. It was originally .NET framework, so it was Windows only. Tried it in .NET Core, which made it available to Mac and Linux and all of these others, which is great. And then we ultimately wrote it in Go, which gives excellent performance, concurrency, single binary, all of that great stuff. And I've got an example here of a GitHub Actions workflow, one of many examples of GitHub Actions workflows, all running Linux, all running Ubuntu, for how to actually pull down and run that binary. So you don't have to have any local tools or anything like that. This just creates a workflow which will copy something from perhaps your GitHub repository, or maybe from one storage container to another. It can work very much like rsync, which is another Linux tool which many of us in the Linux world are familiar with and using for syncing data from place to place. And this is how simple it is to install inside of a pipeline. So I've got this job, which is just pulling down this binary. And this is a little snippet of bash. So it says it's going to install AZCopy. It makes a directory under home/AZCopy. And we're literally just curling down a tar file with that and extracting it to a directory. And inside of that directory, there's an AZCopy binary. And then we've got the AZCopy on there in our CLI. And that inside the workflow, that takes sort of less than a second to actually install. So there's not many different packages, like a package managers in different interpreted languages. You've got to pull down this and pull down that. There's this chain of dependencies, or apt get something down, and it's, you know, it takes a bit to install. It's just literally a second, so it's very cheap. Cool. So we've got some environment variables, and then we just literally shell out to our binary here, and we're using azcopy sync to sync everything that's inside of our GitHub repository into an Azure storage account, which we can also have it, you know, GitHub Actions create for you and a bunch of things like that. But that's one example inside of Azure. But if we look at serverless Go, and we want to say, let's take something which could be an API. It's effectively a very simple web server. We've got an example here which is called, we're going to run on Azure Functions, and it's got a main.go in there, which is the sort of the file you'd use if you were, you know, writing a binary, just a simple binary application that you want to run. So I'm just going to hop in here, and hopefully, I don't know how many of your viewers here are familiar with Go. Maybe we have some Gophers, which is the name for Go developers in the audience, who might be familiar with this.
Yep, I'm going to ask everybody if they have any questions relating to Go or Linux to please make sure you let us know. That's why we're here, to make sure that we answer your questions while we're here.
So this is a really simple example. In fact, I'm also going to pull up another one just in the background here. Sorry if we're jumping around a bit. If I go to ASW 101 and I go 2021 VR, I was hacking on a CLI tool here. So if I go yesterday, going to go to code. These are some other tools actually which are written in Go. We have one called Dapper Microsoft, which you'll be talking about in the future. Kada,
yep, very soon.
Yeah, Kubernetes event-driven auto-scaling is another open source project. We have some SDKs I've been working with, and for Custo, and which is a big data service that is available to customers, and then another one called the Microsoft Authentication Library for Go. And I was hacking on some stuff yesterday that shows really how to build a small sample of a CLI tool. Okay, that's a little bit too simple. Maybe I don't have that one there. I'll push that up in a second. But let's look at this. So this is probably the first blob of Go for a bunch of people. And we can see that this looks a bit C-like. We've got brackets instead of tabs, if you're familiar with Python and all of that kind of thing. You've got functions defined with func main. And you can see here that we're pulling in some stuff from the standard library. So here we've got a main package. We've got some things that we're importing. So Go has a really rich standard library with various packages called funct and things for I/O and logging, and the web server net HTTP. So we go down here, and every binary has a main function. So we've got func main. We have a little bit of error handling here. So one thing Go is known for is that it's somewhat more verbose and takes a different approach to error handling. So it's something, if you're new to it, you'll probably start to have to appreciate after a while. And I've just written, this is a little trick, which basically allows me to handle any errors inside of my function here by just returning the error, and I know that my main function will handle. So this is where all the kind of the work gets done. And the interesting thing about this is how easy it is to build a standalone web server inside of Go that compiles down to a single binary of probably less than 10 gigabytes. So we have the HTTP package, and we're wiring up different endpoints on the web server to functions that will handle that request.
So for our JavaScript users, some of this type of stuff won't be all that unfamiliar.
If you're in Node.js world, you're probably familiar with that. A lot of people, like for the first time they saw having to handle the request and the response and that kind of thing, might have been going from something where that was all kind of abstracted away to something like Node.js. So we're wiring up all these functions, and I've got an endpoint, I've got a health checking endpoint, an HTTP endpoint, and a bunch of other things like this, and some API endpoints, which are kind of wild cards. So it's like everything under API will get routed to HTTP echo, for example. So that's how simple it is just to wire those things up from the start. And then I can do things like get environment variables using the OS package. And I can set that by default to port 80. So I can override these things. I've got sensible defaults, I can override them. This environment variable is because we're going to run this thing inside of an Azure function. and we should have time to actually deploy that using a GitHub action and see that up and running pretty quickly. But we go through this here, we can see that we've got printing some stuff to the console, and then we're just listening and serving. And then we've got something for handling the logs. So you can see this function, every request comes through and it gets passed through this pipeline. So this is kind of like middleware. And the request gets handled. It comes in as a request, and we modify or do something with that request, and then it kind of gets passed back down the pipeline. So here we're just using this to log things like our method and our the URL being requested and the remote address and all of that kind of thing.
Gotcha.
So we've got middleware, we've got a web server, we've got all the kind of things we're kind of familiar with, and now we've got some functions that handle HTTP request and response. So we've got a default handler, which at slash we're going to have the request coming in. Sorry, the request comes in here, and we can write a response. So here we're just going to say that's a 404 because we're building a function app. And then we've got some more complex things like, oh, okay, we're going to have a server name for a health checking endpoint that we can override with an environment variable. And so if that environment variable exists, it's going to say, oh, I'm the Gopher218 server. And we're going to just print that out to the response. So what this does is this just a simple endpoint that outputs this response. You could be outputting JSON, you could be outputting all those different things. Another one that's just super hello world. And this one is an interesting one. Please stop me if you have any questions or any thoughts here. This is a package inside of Go which lets you take an incoming request and dump the entire request back in text format. So we have an endpoint up here called /API. And anything under /API will come in and we'll dump that to a byte string. So we're going to take that entire request, store it as a byte string, and then we're going to spit that back to the client. And what that enables you to do is have a single Go binary which sits behind something like a load balancer or sits on some endpoint, and you can use that for debugging and testing, and you make requests against it, and you can say, oh, requests coming in here are actually appearing like this on the endpoint, so maybe my load balancer isn't configured correctly. Maybe I've got some extra headers and some other stuff like that. And then we've got some other ones here which are actually designed to be specifically run inside of Azure Functions. So Hdp Trigger. So it's just an HTTP request coming in, and it gets triggered serverlessly. You pay per execution. You don't pay for however long the thing is running. You don't have to keep it running persistently. And I have another one here for something called a timer trigger, which is a bit like a cron job. So one of the things we can do with Azure Functions these days is we use this thing called custom handlers, which enables you to run any binary inside of Azure Functions, any binary that can handle HTTP requests. And if it can handle these incoming requests, then you can write Azure Functions in any language. So this was the thing that brought Go support to Azure Functions. Also now supports Rust and Dart and all of these other things that you can run as a binary.
Very cool. So we got about a good 12 minutes or so.
Fantastic.
And so I'm curious to see how this ends up on Azure.
Let's do that. Let's do this the fast way. So without any requirement for local tools or anything like that, and people could follow along with this. We're going to deploy this to Azure using GitHub Actions. So I've created this as a template repository. So if I have here, I can go to ASW1 Go Actions, and I can say, delete my existing one. So we're going to do this live, maybe slightly more risky. I'm going to zoom out a little bit. And I'm going to say we are going to delete the repository. Actually, I'll create a fresh one. So I'm going to say use this template, and I'm going to call this one AzureFunBytes.
Yay!
And I'm going to create this private inside of my repository. It could be private or public, but because a template repository can be made private inside your repo, it's very useful for things you want people to hack on and take away. So anybody can take these pre-made Go functions and so forth, and containers and other things, and they can just clone this and get running straight away. So inside of Azure, one of the things I'm going to do is I've got my AzureFunBytes here. I'm going to go to the Azure folder, and it's going to create an Azure Service Principal. I'm not sure if you've spoken about this on your show before,
Mhm.
but I'm going to use the Cloud Shell, and we're going to zip through this. But basically, GitHub Actions needs to be authenticated to Azure, and we do this with a service principal.
Oh,
And
very cool. We actually went over last week how to create one very quickly for something we were working with.
fantastic. So this is probably one of the longer parts of the thing, but we're going to make it super fast. So I'm going to call this one 2021-0100 AFB for AzureFunBytes. And I prefix mine with a reverse date prefix so that I can easily sort through my resource groups inside of Azure. And I'm just going to paste this snippet. There are docs on how to do this, but the most important thing we're doing here is saying that this service principal is only scoped to the resource group that it is creating. So if we look here, I should see MP1. The resource group that's created, and there's a service principal, and we can copy and paste this blob of JSON, and it asks me to create a GitHub Action secret, so I can go into my settings here, which I've linked out, and I can create a new secret, which back here has to be called Azure Credentials.
Mhm.
And what this does is it makes the Azure CLI inside of it enables us to authenticate using the Azure login function, the Azure login action, and it authenticates the Azure CLI against Azure using that service principal. And then what the Azure CLI is going to do, it's going to run this, we're using this GitHub Actions workflow called toFunctions.yaml, which I'm kind of really glossing through here for time. But it's basically on any commit to the main branch, or any change under the toFunctions subfolder where we've just had a look at that code, it's going to run this bash script called deploy.sh. So this is all vanilla Linux stuff, which is work locally on your local machine if you're running Linux, or in your shell, or in a Docker container, or a Windows subsystem for Linux. And it's going to authenticate. And this bash script contains all the things we need to do to deploy to Azure Functions. It's going to take our application sitting in the subfolder, and it's going to deploy it to Azure Functions. So if I go here, I can see it's simple deploy.sh. Now, if you clone this down to your local machine, it would be able to, and you had the Azure CLI, it would be able to run all of these things for you. It does things like create the storage account.
Bash script.
A bash script, a simple bash script. Like, you don't even have to get into the YAML of Azure Functions. And this is, we're composing these really simple things. Bash scripts, CLI tools, binaries, simple web servers that we can run serverlessly. All of that stuff is really accessible to a lot of people. And in this case, you don't even need to care what this bash script does. But it uses the Azure CLI, creates a storage account, creates an Azure Function app, and then it deploys that by running go build. So it builds your binary using this bash script here. This just runs go build and outputs it with a specific name. It could use a Docker container to build this thing. It doesn't have to, but if you wanted a specific version of Go, you can actually run Docker containers of any kind inside your GitHub Actions pipeline. So you might have a tool chain, which is all nicely installed inside of a single Docker container, and you can just have that be pulled down instead of having to install all that stuff. But it basically zips it up, pushes it to Azure, and then it runs a curl against that endpoint that it's just created. So let's just go and run this thing. So if we go over to toFunctions, one of the things we had in this was a trigger, a special trigger called Workflow Dispatch. So there's lots of events you can run your GitHub Actions based on. This one is on push, and it's also on this thing called Workflow Dispatch. Now, Workflow Dispatch gives you a button inside of GitHub Actions UI that you can manually run a workflow. So I'm just going to manually run this workflow on the main branch. I can pass in various variables as well if I wanted to. I can kind of define those and have it maybe deploy to a test environment or a staging environment, so that kind of thing. Sometimes you need to be able to spin up a test environment to debug something specific, and you might want to deploy a specific version of your app, like, oh, get me the 2 versions ago that was deployed. But it's going to go through and it's going to build our application here.
Very cool. And so now it's going through the process of building our app via GitHub Actions, which is our CI and CD provider. Yes. And it's a functions or I should say actions are free. They're in.
Yeah, you have quite a number of GitHub Actions included by default.
Yes.
Which is there. Let me check something.
Well, I should say if you're just diving in, your first few actions in these situations will be free.
Mhm.
When you start getting into more intricate, larger distributions, and you need to do more testing and you need more runs, eventually you're going to start hitting into some billing situations. But for right now, what we're doing is simple and free.
Yes. So what I'm actually going to do here is we just create. Oh, okay. So I've made a little mistake here. So I'm going to fix this live. Mm-hmm. So our action has failed, and it said that we don't have access to this 20011 GopherCon action that we've created. And so I'm going to go here. I'm going to look at my bash script. It's going to be in functions, and it's going to be called deploy.sh, because the last instruction was we actually set the name of the resource group you're going to be using for you. So if we go 2101, we are 2101 AFB, Azure FunBytes. So I can edit that right there in the UI. And when I save the changes, that kicks off a build. And that's going to start creating all the stuff that it needs inside of my resource group. So that will start appearing there. So I collapse all that.
Very cool. We're in our last few minutes, so.
And what I'm going to do just in the background, we have a very similar web server in the background here called, which deploys an Azure container instance. So we have a similar thing which can deploy an Azure container instance, and by creating a Azure container registry, building your Go application as a container inside of that container registry, and then deploying it as a serverless container. So I can kick one of those off in parallel, I believe we're doing here. So we're deploying a function right now, and we're deploying a container. And all of those resources are going to be created for me. So I don't care how those resources came about. I just know that GitHub Actions is going to create them for me.
And they're all going to happen in order. So if you do one commit, it'll do the actions run for that. And then if you make another commit, you can see that there's more than one for the same file. That's because each commit equates a new run. It's a trigger, and the trigger has it happen. So anyway, Aaron, I'm going to kind of let you let that run, and we're going to start wrapping up. Sound good?
Okay. Yeah. I'll let you know once this is kicked off.
Sounds good. Yeah, we're in the last few minutes, and that means now we get to vibe, hear a little bit of music, and get ready to kind of wrap things up. And while this is running, let's let everybody know where they can find more of your code, more things that you're doing. Why don't you let everybody know? I'm going to go ahead and put up your GitHub again.
Yeah, so the aka.ms/go-actions will land you on this this particular repository, actually. And if you want to chat with me further, my direct message is always open on Twitter. I'm AS_W, as you can see on here. We also have a cool Microsoft open source Discord you can drop by as well, which is aka.ms/open-source-discord. So you can come and chat with us there. We've used that for things like GitHub Universe and a lot of other conferences and things, but it's also a great place just to hang out and hack on stuff. And
well, sorry I couldn't show. Let me see if I can bring this. We're just getting to the end, I think, of it, but there's your job completing.
We're done. Awesome. Here. So we can spin that up actually, and we can see that we have an action here, and we're going to use the Hdp Trigger, and we're going to say hello.
There you go.
Name equals AFB, and there we are.
Very cool. So hey, that's really it. Thank you so much, Aaron. I really appreciate you being part of this today. Obviously, people will go right there, like on mine, to see my Twitter, and then see yours, like there. Thanks to everybody, like Annie, that took part today. We really appreciate you having your say in this. So everybody, why don't we give them everybody, we appreciate your time today. We're going to give you a big wave, and thank you very much, Aaron.
Thank you.
Okay, catch y'all next time. Thanks for joining Azure Fun Bites. We'll see you for another hour of interesting conversation with another person doing something with Azure. See you next time.